welcome to True Projects. In this video, we are going to explain about the project that is LSTM based jamming detection and forecasting model using transport and application layer parameters in Wi-Fi based IoT systems. Before getting into the execution, first let us understand what is the project about. So the Internet of Things, that is IoT, has completely transformed how the industries work. Think about all the interconnected gadgets and systems that make things smarter, like devices talking to each other to make process faster, save energy, and even bring new innovative solutions into the play. And it is pretty impressive, right? And now Wi-Fi plays a key role here. Wi-Fi plays a big role here because it is like the backbone of these IoT systems. It gives us faster data transfers and works seamlessly well with the networks that we already have. But here the problem is IoT devices are often small, they have limited resources and operate on open, unlicensed frequency bands. This makes them easy targets for cyber threats, especially something called jamming attacks. So, jamming is basically a type of denial of service attack. Imagine someone blasting a loud noise in a room, making it impossible for anyone to have a conversation. That's what the jamming does to IoT communication. It sends out noise or a stronger signal to mess up the communication channels. The result? Network performance takes a hit, things slow down, and devices don't respond quickly. And energy gets wasted trying to fix the disruption. So, while IoT is amazing, these vulnerabilities are challenges that we need to tackle with. Here, the industrial environments where IoT is used, jamming attacks can have serious consequences. Imagine a factory where machines are running smoothly, but suddenly communication between devices gets interrupted due to jamming attack. This can cause malfunctions in the machines, delay in critical process, and even create safety risks for workers. In some cases, it could lead to significant financial losses because production has halted or compromised. The issue is here is that IoT devices are especially in industrial settings are designed with limited processing power to keep costs down. This makes them vulnerable to attacks since they don't have the resources to define themselves effectively. On top of that, many IoT systems operate on unlicensed frequency bands which are open for anyone to use. This makes it easy for attackers to disrupt communication without needing fancy or any expensive equipment. This is why it is so important to have a strong protection mechanism in place, especially when IoT is used in crucial areas like manufacturing or safety systems. So, the project that we are working with is aimed at detecting Wi Fi jamming attacks in IoT networks, especially in industrial environments where communication needs to be smooth and uninterrupted. For that, we propose a deep learning model LSTM to be used, that is long short term memory, because it is great for analyzing time based data like the delays or disruptions that occur when a jamming attack happens. The idea is to recognize patterns in the network response times, whether there is a consistent delay which would indicate a constant jamming attack, or random disruptions which are typical for of random jamming. And the system is designed not just to identify these attacks but also to classify them based on how they affect the communication. This is especially important in industrial settings where any communication breakdown could affect critical process and safety. By understanding the network's behavior and the environment it operates in, we can detect anomalies that signal jamming, ensuring that the system can respond quickly and prevent damage before it occurs. So, the system we focus on detecting Wi Fi jamming attacks in IoT network. Here, we use a data set called IoT jamming attack from the Kaggle repository, which is publicly available data set. This data set includes data collected with both the normal communication and also the situations where jamming attacks occur. So we use this data to understand how the network behaves under different conditions. After gathering the data, we pre-process it to extract the most important features that can help us to identify whether an attack is happening or not. And to evaluate all the models built in this project, we are using evaluation metrics that are accuracy, precision, recall, and FN score. These metrics helps us to measure how effective the system is at detecting jamming attacks without too many false positives or negatives. The goal is to develop a reliable solution that can detect both constant and random jamming attacks, which significantly improves the overall security of IoT networks. So this is all about the proposed system. And to further improve the accuracy, here in this project, we are using CNN2D. We are employing CNN2D algorithm, which helps to improve the model performance. The idea behind using CNN2D is that it allows the system to better filter and refine features it extracts from the data. By using two-dimensional neurons, the algorithm is able to focus on the specific patterns and details, leading to more accurate predictions. This process helps to optimize the way the model understands the data, making it smarter and more efficient. On top of that, we have also built front-end using Flash framework. The interface adds an extra layer of functionality by allowing users to interact with the system directly. It includes secure user authentication, so only authorized users can access the system. So here we have included secure authentication mechanism also. So this makes it easier for people to test and evaluate the system performance in a more intuitive and user-friendly way. Moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So let's understand how did we implement the project. First, we have imported all the necessary libraries such as scikit-learn, TensorFlow, NumPy, Pandas, etc. And then comes the data exploration part. Before diving into the model's development, it is important to understand the data set. So this involves inspecting the data, checking for missing values, and getting a sense of features and labels, which helps us to decide how to handle the data. Then comes the part of data visualization. So we have visualized the data, which helps in understanding patterns, distributions, and relationship between different variables. Tools like Matplotlib and Seaborn are used to create graphs like histograms, scatter plots, and heat maps. Then comes data processing. Here we randomly shuffle the data helps and that helps to ensure that model doesn't learn any inherent biases based on more robust. And then comes normalizing. Here we scale the data to understand standard range to a standard range, ensuring that model treats all features equally, improving convergence during the training. And then in this step, we separate the features that is x and the target variable y. So x contains the input data and y contains the outcome whether there is a jamming attack or not. The next step is splitting the data set. Here we divide the data into two parts. One is training set and the testing set. Training set is used to train the model and testing set is used to evaluate the model on unseen data. Then comes model building. Here in this step, the structure of the machine learning and deep learning models is defined. Here layers in the neural network are set up and classifier is chosen depending on the problem. Then comes training the model. Here, the model is trained using the training data, adjusting its parameters based on the input and expected output. This is where the model learns to recognize patterns in the data. Then comes model evaluation. Here, we evaluate all the models which are built using accuracy, precision, recall, and FN score, and we compare through them graphs. Then comes front end. So, a Flash web application is developed, allowing users to interact with the system, and it includes a registration and a login system backend by a simple SQLite database for storing user credentials. And in the front end, users will be able to give feature values related to the IoT attack. And then we have, that given input will be pre-processed at the backend, it will be fed with the trained model. Finally, outcome will be displayed through the front end, whether there is jamming attack or not. So this is how we have implemented the project. Moving on to the algorithms used, these are the algorithms used in this project. SVM is used for comparison purpose, LSTM is a proposed model, and CNN2D is the extension model. So these are the three algorithms used to classify the jamming attack. And to implement this project, we need basically two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB, and hard disk of 25 GB. And coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, we need to open the code folder that contains source code files. So let's open that. These are the source code files in the code folder of the project. Let us understand each file and see how will it be used in this project. So this is the dataset folder. Let's open it. So these two are the files in which we have the data set that we will be using for to train the models to predict the jamming attacks. So here in this file, we will have the attack data. So these are the features. So these features, all these values where the network has these values, it means that there is an attack in that data. So we will be training these models to detect the network attack. Let's close this. And here in this case, where the network contains these kind of features, it means that there is no jamming attack in the data. So we will be training both of these data sets to train the model for predicting the jamming and normal case. And here in this test data file, we have test cases that we will be using in the front end for detecting the jamming attack. Let's get back. And this is the model folder in which we have algorithm information that is stored in .h5 files, numpy files, and pickle files that will be loaded into the project code during runtime. And in the static folder, we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then comes the templates folder. In this folder, we have HTML templates. So it includes index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the notebook.ipynb file. This is a Jupyter notebook file which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I've copied the path. Now open command prompt. Give the command cd, give the space, paste the copied path, and now click on enter. So here if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. Just wait for a while. So yeah, this is the local host and this is the port. This is the address where application has been hosted. So copy this local link provided by the Flask framework. I'm copying it and paste it into any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link, click on enter. And this is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. So we need to sign up first, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. So give your username and the password. I'm giving my username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. Here you can see a choose file button, right? We need to click on that for uploading the test case data. So click on that. So this is the file that we're supposed to upload. Select it, click on open. Before uploading, let's see what do we have in that data file. Let's open the dataset folder, open the test data. So these are the different input values, I mean test cases that we will be giving as input for predicting the jamming attack. So here total we have 11 cases. So these inputs we will be giving as the test cases in the front end. So these level inputs will be given. So let's understand what are these parameters. The first parameter we have is the frequency one. This refers to the frequency at which the communication or signal transmitted. In IoT devices, frequencies are typically chosen based on the communication standard like Wi-Fi or Zigbee. The frequency plays a key role in signal quality and susceptibility to the interference. Then comes noise. This input represents the background noise present in the communication channel. Noise can interfere with the transmission of the data and affect the quality of the signal. Then we have number of packets. This refers to the number of packets transmitted or received during communication. A packet represents a small unit of the data being sent over the network. A sudden decrease or irregularity in the number of packets can indicate potential network issues or attacks like jamming. Then we have delay. Delay refers to the time it takes for a signal or a packet to travel from the sender to the receiver. High delays can indicate issues such as congestion or interference in the network, which could be caused by jamming attacks. Then we have base PWR dB. This represents the base power level of the signal in decibels, that is dB. So it indicates the strength of the transmitted signal. A weak base power level could suggest poor signal quality or interference from the external sources. Then we have RSSI. It is the received signal strength indicator. It is a measure of signal strength received by the device. Higher RSSI value indicates the stronger signal, while lower values suggest weaker signal, which can be result of interference, or the jamming. Then we have REL PWR dB, that is, this is the power of relative power of the signal in decibels compared to the reference signal. It helps to measure the signal strength in the relation to other signals in the environment. Lower relative power indicate the presence of interference or a jamming attack. The last one we have is the average power dB. This represents the average power of the signal over a period of time. This helps to assess the overall strength of the signal. Consistently low average power could indicate the issues with communication quality, possibly due to external interference or network problems. So, this is about the parameters that we will be giving now. Let's get back to the application. It has been loaded, right? Now, click on upload. So the given input, it will be pre-processed at the backend, and then it will be fed with the train model. Then train model will be giving us the prediction. So here we got the prediction for all the 11 inputs that we have given. So this is the first case with these values. For this test case, we got the prediction that normal, where it means that there is no attack in this case. And for the second case, this is the second case, here we got the prediction as jamming attack. So where the network has these values, it will be predicted as jamming attack. For the next case, we got normal. For the fourth case, here also we got prediction as normal. And the fifth case, for this fifth case, we got the prediction as jamming attack. So for the network which contains of these values, there will be a jamming attack. Similarly, for all the cases that we have given, we got the prediction. If there is attack, it will predict as jamming attack. If there is no attack, it will predict it as normal. Now let's check with the graphs. Click on graph. So here we got the graphs. This is the confusion matrix graph of the extension model CNN2D. Here on x-axis we have predicted class, and on y-axis we have true class. Here this yellow color diagonal represents the true predictions, that is correct predictions, and these purple color diagonal represents the misclassifications. If you observe, there are no misclassifications. And here this is the accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithm names that are being trained to predict the jamming attack. And this is the precision score comparison graph. This is the recall score, and this is FN score. Now click on sign out. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.